Hey, I'm Kurt, and this is another episode in my Introduction to AppleSoft Basic series. In the first episode, we went over variables, we went over writing text to various places on the screen, we went over how to program in AppleSoft Basic and how to edit those programs. We touched on the low-res graphics mode and the high-res graphics mode, and we also did a little bit of audio. In the second episode, we focused on getting user input from the keyboard and also touched on looping of programs and rounding of numbers. Now in this episode, the third episode, we are going to focus on random numbers and having programs that are unpredictable. Computers, as you probably know, are very precise and very exact by their nature, but sometimes programmers, they need a little bit of imprecision or unpredictability in a certain program, or especially in a game that they are designing. Imagine a game that is a maze that the player has to find their way out of. And imagine that every time you play that game, the maze has the exact same pattern, and so the solution to getting out of that maze is always the same. That would get pretty boring for the player after a couple of tries. So all computers, they do have ways to generate randomness. Let's see how that works on my Apple IIe computer from 1983. So I am going to power on my computer, and since I don't have a disk in there for the computer to boot to, I'm just going to hit Control Reset, which will tell the computer to bomb out into an AppleSoft Basic prompt. And now I can type any AppleSoft Basic commands that I want to on this prompt. I can even write a program. Don't need a disk at all. Now for generating a random number, AppleSoft has one single function that does that. It's called RND, which is short for random. Now the RND function, and I'm just going to call it the random function, it takes one single argument, and the argument's a little complicated. If you put a positive number into the argument, any positive number, that tells the random function to give me a random number between 0 and 1. And that's what most people do, 99% of the time. So we're just going to focus on that one case. Let me show you an example of generating a random number between 0 and 1. It's very simple. We don't even need to write a program. We can just put on the command prompt, we can put A equals RND, and then put a positive number, let's say 5 for funsies, into there. And so now A holds that random number, and we can print A, and you can see that is definitely a number between 0 and 1. Now, just in case you're not convinced, let's do it again, and let's put another positive number in there, maybe even a bigger one. And this positive number we're putting in there, it doesn't change the way that the random function works. It's still going to give us a number between 0 and 1. So if I print A again, we'll see that it is still a number between 0 and 1. So from now on, I'm just going to put a 1 into the argument just to make things easier. So since the random function always generates a number between 0 and 1, what happens if you want a bigger number than that? Well, then you just have to multiply it by whatever number you want. So, for example, if you want a number between 0 and 100 rather than 0 and 1, you just multiply that result by 100. So A equals RND of a positive number, and you multiply it by 100, and now it kind of looks like a small number still, but let's do it again just for funsies. A equals RND 1 times 100. Oops, did that work? That actually worked. Forgot to put the space in there. So that's a much larger number. Okay, well, now we're getting somewhere. Now we can do something cool in a program with this random number generator. What if we wanted to get a little bit more focused, a little more exact? What if we wanted a number between 90 and 100 instead of 0 and 100? Well, with a little extra logic, you can easily make that happen, even from the command line. 90 to 100 is only a range of 10, and that is what we have to multiply the function by. So if I do A equals RND of a positive number times 10, that's going to give us a a random number between 0 and 10, but we really want that shifted up to 90 to 100. So all we do is we add 90, and now we're going to have a random number that is between 90 and 100. So the random function always generates a floating point number, as you can see. What if we didn't want to float? What if we wanted an integer between 0 and 100? Well, in that case, we can use the integer or int function, which we learned in a previous episode. And a one-liner way to do that is put the int wrapper around the random function. So if we wanted between 0 and 100, we multiply the random by 100. So this is 0 to 1. Now we're going to get 0 to 100. And then if we wrap the integer function around that, it will basically lop off the decimal places and give us a nice round integer, like 61. Now it turns out that the random function is not inclusive. It doesn't actually include 1. When I say it's generating a number between 0 and 1, it's actually generating a number between 0 and 0.9999999. It does not actually include 1. And so as a programmer, you need to know that and understand that limitation, and you need to understand that that far right edge case of actually hitting the 1 is never going to happen, and take that into consideration in your program that you're designing and that you're writing. Now I'm going to create an actual program that is going to use the random function in order to give you a simple example of how it might be used in a real program. So let's write a program that simulates a coin toss, and a coin toss only has 2 outcomes. So we can write some code kind of like this. That's easy. This is very similar to what we were just doing at the command line and not creating a program. But let's go ahead and run this and see what it gives us. Let's run it a few times. Rum. And if I didn't, I was getting a little worried there. If I didn't have any bugs in my program, it's going to sometimes give us a 1, and it's going to sometimes give us a 0. Because this is giving us a random number between 0 and 0.99999. Multiply that by 2, and you get a number between 0 and 1.9999999. So when we truncate it with the int, it's always going to lead with a 0 or a 1. The 2 is the far edge case that I mentioned that'll never, ever, ever, ever happen. So because we know that we can put a 2 in here, and we'll always only get a 1 or a 0 as our output. We talked about how the integer function truncates instead of rounds in a previous episode. Now, let's add a loop, and let's do that 100 times, and we'll have it tell us whether it was a head or a tail versus just printing out 0 or 1. Now, when we see the whole program, we put a for loop, a for next loop, around that, which we learned about those in a previous episode. And so it's going to do this 100 times, and it's going to tell us whether each time was a head or a tail. You can see, looks like there's some randomness there. It went off the screen, but you can see multiple heads, and then a tail, a couple more heads, a couple more tails. Definitely looks pretty random to me. But it scrolls off the screen, so let's just tweak this program a little bit, and let's actually count the heads and tails instead of printing out the words heads and tails. So let's add a few more lines. All right, let's look at our new program. So now we're just going to keep track of the heads and tails and then only print out the value at the end. So let's run that, see what happens. We got 51 heads and 49 tails. Let's try it again. different number of heads and tails. So you can see how truly random it is by running this multiple times and seeing how the numbers come out differently. A random function like this is not going to be perfectly 50-50. You're not going to get, occasionally you might once in a while get 50 heads and 50 tails, but a true random function is not going to be very even like that. It's going to be random. I mean, that's what it is. It's random. Now, before we go, I want to spend just a couple minutes talking a little bit about my Beagle Brothers catalog. This was printed in 1987, winter spring 87, volume 0, number 10. Beagle Brothers, I really loved Beagle Brothers. They're based out of San Diego. They call themselves a micro software company because they didn't make big apps like a big word processor or a big, Photoshop kind of app. They made tiny little utilities or helper apps that helped out some of these bigger programs. So let's look at a couple that are in here. Let's take a look at a little program they call PowerPrint. PowerPrint is a dot matrix printer utility, and it costs $40 in 1987. PowerPrint lets your printer do what it was designed to do. PowerPrint lets you, quote-unquote, download a second type style or a second font into your printer's memory so that you can alternate between your standard printer font and a custom font with special characters and symbols. Can you imagine sending something to a printer and being limited to having only one font? Well, now you can have two fonts. Isn't that great? It lets you mix graphics and text. Can you imagine that? Mixing graphics and text on a printer. For example, you may design up to 96 custom printer characters that combine to print a small illustration like a logo. You have to design 96 custom characters that when put together or combined, they create a logo. This sounds like a little bit of work, but I never had PowerPrint, so I don't know how easy or hard it was. PowerPrint works with any version of Apple II as long as you have 64K, and like all Beagle software it mentions, since 1980, disk backups can be made without a hassle. When you buy this, you can make backups of it without a hassle. So that's pretty great. Let's look at another program that another utility that Beagle Brothers put out in 1987. It's called Beagle Screens, and it's pretty amazing. So it is a full screen captionable clip art. So remember clip art? You used to buy these CD-ROMs full of these little bitty clip arts. You can get clip art on the internet these days, but back in 87 you had to buy them on floppies. Well, Beagle Screens, for only $35 in 87 money, will give you a selection of full screen clip arts, and every single one of them have this little text area that you can customize and create your own text. And so you have a customizable clip art, full screen clip art that gives you a message, and that's pretty great. There are 40, not 10, not 20, but 40. Can you believe it? There are 40 pictures in this library just waiting for you to add words to. Beagle Screens pictures may be used as professional looking title screens on your AppleSoft programs. You can use these on your own AppleSoft programs. That is amazing. Or you can create personalized on-the-screen Apple slideshows, which is fun. Or you can have a dot matrix printer and printer dump software like Triple Dump, which we, by the way, sell on page 10. And using software like that, you can print these Beagle Screens as fancy signs and have them on paper. What about animation, you say? I can't do this without animation. Well, not to worry. 20 of the 40 pictures are automatically animated. As soon as they appear on the screen, bam, they're animated. Beagle Screens two-step back and forth animation. So they're slightly animated. They toggle back and forth. This is great. Beagle Screen's two-step animation gives your messages extra punch. Pow! Love it. So that is a quick look at some of the software that you could buy in 1987 from the Beagle Brothers catalog, which is just amazing. So now that I have thoroughly sold you on buying something from the Beagle Brothers catalog, that is going to be it for this episode. So I really want to thank you for watching, and I want to thank you for your interest in these videos and these topics. If you have any feedback for me, or if you have any ideas for different topics, or ideas of different things that you would like me to do, leave me a comment below in the YouTube comments, please. And until next time, I will see you later. Using that code we got, and none of this was in focus that entire time, so I'm gonna have to shoot this again. Shoot. Now, what AppleSoft has, holy cow, that was a SpaceX rocket landing. Let's do that again.